Okay, the first section of chapter 5 is about different pieces of the parabola or quadratic equations. And we've already looked at the vertex form for graphing quadratic equations and getting parabolas down on the graph. So you should know how to find this vertex for HK, if that's how the equation is given to you. But you'll notice this is the standard quadratic form. So this is a new way of seeing the quadratic equations. And you need to become very familiar with it. Y equals ax squared plus bx plus c. When you are given this form, you will need to be able to take those coefficients, a and b, and that will help you find this first piece of a parabola, which is called the axis of symmetry. You know, we've discussed before that parabolas have symmetry. One side reflects the other, and it looks exactly the same. So when you take the coefficient on x and the coefficient on x squared, you have this fraction, negative b over 2a, which gives you x equals, which is a vertical line, which is that axis of symmetry, which cuts the parabola in half. The next piece of the parabola that you can find using bits of the quadratic form, the standard quadratic form, is the vertex itself, which when you have it in vertex form you can find very easily by glancing at the quadratic equation, but not so much in standard form, is the negative b over 2a common y. This is a ordered pair, and if you'll notice, this is exactly the same as the equation from the axis of symmetry, because the axis of symmetry is a vertical line whose all x values are exactly the same. It actually runs straight through the vertex, and that should make sense. The vertex will be the lowest point or the highest point on the parabola. We'll talk more about that. So once you find the axis of symmetry, you have the x value of the vertex. Now where would we get y from? Since the equation is y equals, once you have this x value, you can plug that into, substitute that into your equation and solve for y. So you would have this coefficient times your x value squared plus your b coefficient times your x value that you just found plus your c. And of course some of those could be negative values. Something else you can determine by looking at your equation is whether your parabola has a maximum or minimum. You won't have to do anything else but take a look at your equation. Which parabola here has a maximum, which has a minimum? Obviously, looking at the graph, you'll be able to tell, but we wouldn't even need a graph. We could just look at the equation. So if we have a, which is negative, that would mean I would have a downward facing parabola, so my vertex would be at the top, and I would have a maximum. If my a value is positive, that means that I would have an upward facing parabola. Therefore, my vertex would be at the bottom. So I would have a minimum. And those are things you can tell by just glancing at, taking a look at your equation. Let's not look at that entire problem all by itself. So, given a quadratic equation such as this, let's find the axis of symmetry, which is negative b over 2a. So your b is negative 6, your a is 4. So here's our axis of symmetry. Let's reduce that, and we get our axis of symmetry is 3 over 4. And we also know that's the first part of our vertex. So if we plug in, substitute in 3 over 4, and you can square this. You can multiply it by 6, square first, then multiply by 4. What we end up here is with 21 over 4. That reduces to 5 and a fourth, or 5.25. And this is 3/4. Roughly sketched, you should know by looking at your equation, which we just discussed, that this a value is positive. It is an upward facing parabola. And we could graph this on the coordinate plane. Positive value, you should know that this would be in the first quadrant of the coordinate plane. Something else we can be asked for is, what is the minimum? What is the maximum? Does the function have a minimum or maximum? Okay, so what they're saying is, take a look at this quadratic equation. What is your a value? Our a value is 3. It's positive, so that means I should have an upward facing parabola. So that means my vertex should be at the bottom. I should have a minimum. So what you're going to do is, this function, the minimum or maximum value will be what we get as our output, this f of x value, meaning what is the y value. So we'll evaluate all of this for our x. So that means we have to go find that x value, which is negative b over 2a. So we take b, we take a, and we find out it's negative 4 over 3. We will put that back into our function, and we will find, remember, square before you multiply, and we will find that we get a negative 1/3. We already established that this was a positive a, so we should have an upward facing parabola, meaning that the vertex is at the bottom, and this was a minimum. So remember, f of x is the same thing as y, so our minimum value is negative 1/3. Something else you can be asked for. And last, we had already discussed this. Can you predict the maximum or minimum from the equation? And that is what we had just gone over. Basically, this should not be a square, that's just x. So let's just say on the left, would you have a maximum or a minimum? Well, a is 1 on that x squared. Ignore this. This should not be a squared. So if that is a positive a, then you have an upward facing parabola, and you will have a minimum. How about this equation? You have an a which is negative, so you would have a downward facing parabola, so you should have a maximum. Come with questions, we will answer them and find those pieces of the parabolas.